Hi guys, my name is Yash Naik and I am a master student here at the USF. I'll be working on World Development Indicators project, but my main focus is on unemployment and CO2 emissions. My main purpose for working on this project is to identify how unemployment is spread throughout the world and which factors affect it the most. The project is mainly about unsupervised learning and visualizations. I have used k-means clustering and correlation matrix to identify correlation between different countries. Not different countries, but different indicators. For the visualization part, I have included few world maps, line graphs, and correlation matrix with the help of a few different libraries like R World Map, Color Brewer, and many others. Now let's talk about the dataset. I got this dataset from Kaggle.com and on which it was uploaded originally by World Bank. Dataset is quite a big. Its size is 0.5 GB as you can see, but I didn't use whole dataset for my project, so I just used some part of it. The original dataset includes 1344 different indicators for 247 countries, regions, and other groups from 1960 to 2014. So now you can understand why this dataset is so big. The main problem with the dataset is that it is not complete. There are so many missing values and countries' names are different from their official names. In order to understand this data properly, I decided to filter out the names of all the countries and indicators used in this data. From that information, I created a new data table, which you can see on your screen. First column is indicator code, second column is indicator name, third column is the number of countries for which that particular indicator has values, fourth column is number of years, so how many years that particular indicator has value for a particular country. The sixth and seventh column are the first and last year of that for that indicator, and the final column is just the difference between last and first year, so it will give you the span for which that indicator has values. As I have mentioned before, there are some mistakes in country names, and I was able to find out an online correction list for this dataset and used it in my project. Now let's talk about unemployment in 2014. This dataset provides latest information about unemployment is of 2014. I used R World Map and R Color Brewer libraries to put a world map for unemployment 2014. I connected values for individual countries to their spot on a world map. Lighter the shade, better it is, as unemployment rate is relatively low in those countries. Few countries are left gray because there are not enough data or no data for those countries. And here you can see the map, and you can see that many African countries are suffering from high unemployment rate, and most of the Asian, Australia, South America, and North America have pretty much same unemployment rate. This information is useful, but this doesn't tell us about the change every year countries make in their unemployment. So we can get a better idea about it if we know about year-to-year change for unemployment in all the countries. We can use clustering for that purpose. Here I am using k-means clustering to make clusters of countries. In order to know what is the optimum number of clusters I should use, I am using a for loop which will check all the numbers for clusters from 2 to 15. And based on that loop, I have created this line graph, and you can see the y-axis here is within group sum of square divided by total sum of square. So the choice here I have made is 3 clusters to get maximum possible variance covered. These are the 3 clusters that I got from clustering. This plot was made by ggplot2 library. Data was centered before using, and that's why we can see some negative values in second and third cluster. These are the three clusters. You can see first cluster has a steady line which shows that these countries haven't experienced much changes in their respective unemployment rate. Countries in the second cluster has made substantial progress in their unemployment rate throughout these years from 1990 to 2014. At the same time, countries in cluster 3 are struggling to keep their unemployment rate under control. Again, here I have plotted these clusters on a world map. Now the question is how to measure this change in unemployment rate. So to measure this change, I am using a linear model in which last year's value for unemployment rate is the response and all the earlier values are variables. After getting all the coefficients from this linear model, I am plotting those points on the world map to visualize it better. Again, lighter the better. This is the world map from the coefficients. So here you can see some countries are darker because they cannot control their unemployment, and some countries have lighter shade because they are doing much better job at controlling their unemployment. Before making any conclusions, we need to check if geographic location affects the unemployment rate of a country or not. In order to do that, I have divided world into 7 different regions and compared their unemployment rates throughout the years. These 7 regions are South Asia, East Asia, North America, South America, Middle East, Europe, and South Africa. So let's see what this graph tells us. So we can see that South Africa is way above average than the other regions of the world. So that means if some country is in South Africa region, then no matter how good their government or their people do, but they are still gonna suffer from unemployment rate. And here you can see in North American line there is a big jump in unemployment rate from around 2007-8, and we all know that it's because of the housing market crash. Now let's talk about the carbon dioxide emission per capita. It is not obvious to see relation between carbon dioxide emission and unemployment rate, but as we all know, our new president believed that because we are imposing so many environmental restrictions on our businesses, here we are not able to compete in the international market, and because of that having less manufacturing units in the US, and that leads to unemployment. So let's find out whether this there is some truth behind it or not. I am using CO2 emissions per capita indicator here. Here this map will tell you about CO2 emissions in 2011 throughout the world. Now here I again used methods as before about clustering, how many clusters to make, then how to visualize those clusters. So I decided to go with 3 clusters to continue harmony with my earlier clustering process. Here you can see the first pink cluster is below average, second cluster is exactly the average, and the third cluster is the blue one is above average. So if one country is in the blue region, then they are definitely producing more than they should. Now let's talk about carbon dioxide emission by region. You can see the green line is the most distinguished one. It is of East Asia, the fastest growing region. Europe and North America, which are second and third respectively, are still high on the radar, but they have achieved equilibrium state, and they are not increasing the amount. Our last section is about correlation between these indicators. These indicators are about CO2 emissions, expenditure, education, international migrant stock, exports, imports, alternative energy, coal usage, population growth, youth literacy rates, scientific and technical journal articles, military expenditure, and unemployment. I took a p-value as 0.05 to decide correlation between these different indicators. Here you can see the visual form of correlation matrix, and you can visually see the relation between one and all the other indicators. If it's a blue ball, then it's a positive relation. If it's a red ball, then it's a negative relation. Conclusions. Location is very important or for a country's unemployment rate. As we can see, Africa is ahead of whole world by a mile in that indicator. Even though China has highest CO2 emissions, they are behind in CO2 emission per capita than US, Australia, Saudi Arabia, and many other countries. As a rapidly growing region, East Asia has exponential growth in CO2 emissions every year. They are now leading North America and Europe, but North America and Europe still have high number, but they are just steady now. Correlations. Countries' exports is adversely affected by its CO2 emission. Countries' exports is not at all affected by coal usage. In fact, it is adversely affected by it. Surprisingly, population growth is not related to immigration at all. CO2 emission has negligible effect on unemployment. Coal usage has also a negligible effect on unemployment. Reference used. These are all the reference I have used for making this project, and a big thank you to both the teaching assistants and the professor to teach us valuable things. Thank you.